Hi, I'm Alvin Aniwa. My student number is 100-603-501.
My name is Victor Zhang. My student ID is 100421055.
My name is Angela Tabafunda. My student number is 100-622-426.
This is a project. We're an even numbered group when all of our student numbers are combined. So our project was
A Space Invader game, kinda.
our code is based off our second lab. When an FBO is bound to a target, GL read buffer selects each buffer of the frame buffer object to read, and GL draw buffer selects which buffer to write to. The frame buffer is the final rendering destination in the OpenGL pipeline and renders a scene on a 2D display. The frame buffer is managed by the Windows system, and this is how FBOs work. Though the frame buffer is the final step in the graphics pipeline that we see, there are many steps before it. The pipeline first starts with vertex data. The vertex data is sent to the vertex shader, where the vertices are placed in the right coordinates in the world. Next is the geometry shader and primitive assembly, which connect the vertices to make primitive meshes. Then comes the rasterizer, which converts the primitives from vertices to pixels. After the rasterizer comes the fragment shader, which colors the pixels. After is the depth and stencil buffer, then the color buffer blend, and then the differ, and finally the frame buffer. To achieve bloom, 3 passes must be computed. The first being the bright pass, which is responsible for determining which pixels are highly illuminated. The second is the blurred bright pass, which adds an aura around the bright pixels. This is accomplished by implementing a 2D Gaussian blur. The third and final is compositing. It is simply binding the blurred bright pass texture and the original scene texture, and this is basically the bloom effect.
So now for our color correction, we decided to apply a lookup table or a LUT to apply a custom color grading to our enemies here. And you can see that it has like a weird, like a bluish tint to the speculars and such. So here we'll jump into the code for that. So for this, I implemented a LUT class that stores and helps me bind the LUT table. So I also made the LUT FBO. So here we would clear the LUT FBO, bind the the color gradient, then set the materials to that, sample it from the default FBO, and then we would save it. So for that, what we do is we component it together in the final bloom. So it will be added up together, and then it will display it only in the final version. And then now move on to the blurring or bloom. So for the blur and bloom, we start off with a default. And then from there, we do a bright pass on it. So this, what it does, it only takes the bright colors. From there, we blur those bright colors for this effect. Then with the blurred bright pass and the default, we combine them together to get a glowing effect, the bloom. So for that, what we do is we run a bright pass. So what this is it runs a shader that goes and picks out the very bright colors, and then it stores it and then cuts off everything that's dark. So after we get that, we would run a blur. In this case, we're using a Gaussian box blur, a weighted Gaussian box blur, to blur the bright pass colors to give it like a smudged feel. a smudge. So we're spreading the color around so that the surrounding areas will be lighter. And then from there, we compact it into the bloom. And I'll go into the shader a bit. So in the bright pass, all we do is we just allow a threshold so what colors can go past. So we're sampling from the base and then we allow what colors to go past. And then from there, we just take those colors, then we put it into the Gaussian blur. So this is a Gaussian box blur that has a set weighting, and it would blur each element that is in the bright pass, which to achieve a nice blur. And then here we're looping it through many passes to get a really smooth blur. Then after that is done, we would go into the bloom. In this case, we sample each of them and then we composite them together to get the final result. And that is our tutorial for Space Invaders.
So for implementing specular, ambient, and diffuse lighting, we've managed to like combine all of these into just one lighting calculation, which is through using Phong model. So, oh no! So to do this, we've passed in several uniforms for light ambient, light diffuse, light specular, as well as constants for our attenuation. Over here in our shader, we calculate all of the individual lighting, like our attenuation, which is like multiplied to the ambient. Here's our ambient calculation, here is our diffuse calculation, and here's our specular calculation. We add all of these lighting calculations together to do the Phong, and we just outcolor it here in the main so that we get the light, the nice colored lighting. Not really colored, but yeah. So if we wanted to, if we would just want to see specular lighting, we would just like have the other uniforms as 0 and then just keep the ambient, or let's say the diffuse, as like whatever value that we want and have the rest as 0. That way that we can just isolate that lighting, since our Phong model is just an additive of all 3 lighting here. So if we want just ambient lighting, we would just make diffuse and specular 0 while having having something on our ambient value. Whereas if you just want specular lighting, we would just have ambient and diffuse as 0 and then have the specular as something else that we want. So that's basically how we implement our specular, light, and diffuse all in one shader by using Phong.